2013. Laboratory scale production 2014 to 2019. And somewhere here is a little nixie tube factory. So this is hopefully 2020 something. But before we can actually start with something like a little nixie tube factory, we have to do several things. We need to find answers for several questions. This will be planned for 2020. So the main challenges, which were with us all the years, leakage and cathode poisoning. The first one, leakage, this is a failure. On the bottom of the nixie tube there are 11 wires going through the glass, and if the glass to metal seal, the seal between the wire and the glass fails, the air can go in and the tube fails. So this is a real failure. And the second, cathode poisoning, this is a natural wear on nixie tubes. This is the situation when some parts of the digits doesn't glow at the same intensity as the others. This builds up over time when the nixie tube is running, and our goal for this year will be to understand the exact mechanism, how the cathode poisoning behaves and how it is built up in the nixie tube. My dream or plan for the upcoming years is to establish a production of slightly smaller nixie tube, which will be produced in higher quantity, and thanks to the higher quantity we will be able to decrease the price for customer. But before we can actually start with the factory, we need to go through this and solve these things, because if we scale from the laboratory production to the factory directly without understanding deeply these two things, it will cause problems in the future. So far we spent most of our time in the leakage problem, because this was the thing which caused us the biggest struggle. So far there were a few hundred tubes failed from the quantity of roughly 9,000 tubes what we manufactured. In average, it makes 3.7% failure rate. Over the years, we implemented several improvements into our glass to metal sealing technology and also into inspection procedures. And this helped us to bring the failure rate from roughly 8%, what was at the beginning, to below 1% for the recent tubes. So the main point is that we've been successful in bringing down the failure rate of our nixie tubes. But there are still some questions and problems which are not which are not clear for me. So next, the cathode poisoning, as I mentioned, this is the natural wear on nixie tubes. This is probably the limiting factor in a lifespan of a nixie tube. When the nixie tube is operating, there is a metal evaporated from the running digits, from the cathodes, and it is ejected into the space. And the general opinion about the cathode poisoning is that this metal traps impurities in the gas, and this compound of the metal atom and impurity settles on the digits, and if this deposit is thick enough, it builds some kind of like a barrier for the glow, so the glow cannot glow at the same intensity as the healthy part of the digit. The life expectancy from nixie tube is roughly 20 years, and now we need to find a way how to make sure that our nixie tube can last so long. So I need to develop some kind of model, because we cannot wait for 20 years to be sure that the nixie tube is good. We need to find some accelerated model or accelerated aging or something like this. And this is not so easy, because if you, let's say, increase current or decrease current in nixie tube to speed up the processes inside, you are changing the processes. So there is something different. There is something different going on in the nixie tube, and it's not so easy to extrapolate it to our normal running parameters. What I did, I will show you. Several We want to simulate different behaviors and different operational parameters for the nixie tubes, so we understand better what's going on inside and how it influences how the manufacturing techniques influence the behavior of the tube and how it influences the lifespan of the nixie tube. So, for example, this test, we have 6 tubes, each of them permanently displays 1 digit, and we want to see what other digits are influenced. Let's say what digits are influenced by number 5, what digits are influenced by number 4. So the theory is that the adjacent digits, which are closest to the glowing digit, will be influenced, but we want to see how far can the sputter get from this number, how far in the tube. So for example, number 6 is in the front and will it influence number 2, which is in the back, we don't know. So we need to test it. We do this test with our own nixie tubes, and as a comparison, I took iron 12 Russian nixie tubes, which are very available. We can make a comparison test between our tubes and the original nixie tubes. The iron 12 turned out to be quite reliable from what we can get, and I think this will be quite representative test. So then after we have some data, we can compare these two digits. We have also other tests running here. Here we have leaky tubes, and we are observing how the leaks advance over the time. Here we have a nixie tubes without mercury. If you remove the mercury from nixie tube, you speed up the processes by a factor of 40. So let's say we have a lifespan of 20 years for a regular nixie tube. If you remove the mercury, you can count with something like half year to 1 year of flawless operation. Apart from the permanent digits, we have regular clocks with different settings of cathode poisoning prevention, which is this effect like going back and forth digits in the nixie tube, and so we are testing many different settings here. Some boards are with different manufacturing techniques, let's say with longer pumping or different cathode activation and this kind of thing. So how it works? So the tests run like this all the day. The clock boards are connected to cameras, so they have like a remote shutter. And once per day, each night, they make a series of shots. So we have a picture of each digit, let's say all number 5, all number 6, and then like this. So over the half year or 1 year, we will have a series of frames, and I will be able to make a time-lapse video out of them, and I will be able to observe how the brightness change and how the cathode poisoning develops, how the leakage develops, whether it is linear or jumping and like this. So I guess that this thing will give us a lot of answers for our questions. We have all the manufacturing data about our nixie tubes. We collect data like pressures, temperatures, and all these things from the manufacturer. For every nixie tube has a serial number, and for the serial number we have this information. Apart from the manufacturing data, we have also the reliability data. So whenever there is a nixie tube which failed, we have this information in the database. So as you can see here, the leakage problem goes down. Here this was roughly 8%, 6%, and here these tubes, this is serial number. So here in this region where we are, it's already below 1%, and we want to maintain this level. There was a lot of improvements along this way. We want to improve it even more. This is cathode poisoning if the tube runs in a device which contains a cathode poisoning prevention, like a clock with this effect. The cathode poisoning should not appear in the clock. But if it happens, we replace the tube and we consider it a failure. So here we have a statistics for the cathode poisoning. As you can see here in this region, all this is caused by the fog problem. I was talking a little bit about this problem on our blog. I want to make a really in-depth video, but this will take a lot of time. Apart from the problem, there was impact on purity of the gas inside the tube, so we had some failures on the customer side. So here in this region we tried to bring another improvement into our production. The intention was to purify the neon entering the tube, but as a result it was actually making it worse. So again, as a result, we had several warranty claims for customers, so we replaced the tubes, and you can see them here in this chart. So to study the leakage and the kettle poisoning more in deep, we need to build a device which will analyze the gas inside the tube. We already tried several techniques how to analyze the gas purity inside the tube, but they were always indirect and not working very well, because we are talking about very low amount of impurities which have impact on health of the nixie tube. So we need to have something really precise. So the easy ideas didn't work. So I'm now trying to come up with something more complex to build, but which will work really well and give us a lot of information. And this is a machine which I saw in a documents describing how people analyzed CRT tubes in the past. There was a ultra high vacuum system which was connected to the CRT tube, and there was a system how to open the tube directly into the system, and you would have a residual gas analyzer connected to the ultra high vacuum system, which would analyze the gas coming out of the CRT tubes. So we need to build a similar system. We will have a perfect idea about the composition of the gas inside the tube. There are a lot of problems connected to this, not only the cost and the time what we need to build this thing, but also the representation of the data and time what we need to spend on every test, like the connection and these things. But this is the task for this year. I would like to thank to all our customers who purchased a nixie tube or a nixie clock in the past from us. All the efforts what you see in these videos are only possible thanks to you, because in the end it's you who pay for this. So thank you very much. Without you we would not be able to make nixie tubes. I would be just dreaming and maybe reading about manufacture of nixie tubes, but with you I'm able to actually following my dream of building a small factory for the nixie tube. So thank you very much, and thank you also for the patience with when something is not running as it should, because there are a lot of things. So if you have failed tube or the firmware in the clock was not running as supposed, thank you for the time you gave us to solve this problem. That's all for today. I will bring more videos about how we evolve from the nixie tube laboratory into nixie tube factory. I hope that you like this topic. So there will be more videos on this YouTube channel. For me personally, this YouTube channel is one of the highest priorities for this year. I'm really motivated since last October, when I discovered the Wintergatan channel. Maybe you know this channel. It's very exciting project, and this was exactly, when I saw it first time, this was exactly the way how I wanted to document our work. So the first day I saw it, I immediately ordered new camera and some other camera gear to start shooting. So there was not so much time to actually do videos, but I want to change it for this year. So I will do more concentrate on the nixie tubes itself. We have several partners for production of the nixie clocks. They develop their own nixie clocks, and I want to just deliver the nixie tubes if possible, because this is the main thing what we do, the nixie tubes. And hopefully it will take some work from us so that we can focus more on nixie tube and the YouTube channel. Okay, so thanks for watching. A few last words before the sun goes down completely. The plans for 2020 are: we will start preparation of manufacture of new small nixie tube, and we will be looking for the answers for the last questions we have regarding to the nixie tube technology, so we can evolve from nixie tube laboratory into little nixie tube factory.